are the UMP tech titans. Imagine. No, it's fine. It's fine. Yes.
I've paused the time.
No, we sorted now.
You are ready?
Which thing?
Okay, can go.
Fraudulent claims in South Africa's healthcare system has become a really critical issue. According to a study conducted by Letlogo T, 10 to 15% of claims are fraudulent. They contain false information. And that sums up to an annual loss of approximately 22 billion rands trying to compensate for the fraud. We have the types of fraudulent claims, which are duplicate claims, where medical care practitioners claim twice for the same claim. We have phantom billing, where they claim for services that are not even rendered at all. And then we have card farming, which according to Experian, it is the most common because if they can get a hold of your card, then they can be able to access your medical benefits. Ask those who have gold and silver tooths exactly how they got them. So this is a problem actually because it causes economic burden. Now, prices have to go high, which is kind of very unfair to those who are genuine, right? And then with this increase in prices, now people have to turn to the public healthcare sector, which we know that most of our public hospitals, like Rob Ferrer, are understaffed, usually find just one doctor, and it can be overwhelming. So it also causes resource misallocation. Imagine the 22 billion rands that was now used to compensate for the fraud. Could have been used for other things like improving their infrastructure or their service provisioning, right? And erosion of trust. Imagine consistently and persistently paying for a service whose quality stays stagnant or maybe even degrades, but then you have to increase the prices. It is not fair, right? So that is why we are here. Over to you, Mom.
Thank you for the lovely introduction, Ms. Malaza. Now I will continue with the aim of our system. Our system was, the aim of our system is to develop a robust and scalable machine learning based system that will be used to detect and prevent related or health related frauds. Our objectives are to investigate historical health care claims data, and also to design and train a predictive machine learning model, and also to assess the performance of the model using using predictive model matrix. I'm sorry for stuttering. We also have our methodology, which we have our methodology, which involves the use of data science life cycle. And I would like to pass on to our second colleague.
Greetings, everyone. So I'm going to continue where my colleague left off. So he was talking about the methodology. So we were given the data set by the sponsor of the Datathon, which talked about medical records and the claims. So we consider that one as an internal data set because it was like compulsory to use it. And then we also looked for another data set because we couldn't use that one as our primary data set to develop the model because it kept on going down. But we looked for a data set that had more features that are common with that one that we were given by the sponsor of the competition. So the data set that we got had even more columns that we can use for our machine learning model. And then now when we explain the data processing, here it's where since we were given the relational database, we had to combine tables according to their relationships, which are made by primary keys and referential keys. So we joined those tables, and then after that, we then explored a small portion of the data set, since the data set that we had on the database was a lot. We couldn't load the whole data set because it was going to be, we are going to have a constraint of memory. And then we normalized and scaled the numerical data so that we can improve our machine learning performance. Like our machine learning models performance. And then we also did the feature engineering so that we can know the features that we are going to use on our models. And then when it comes to data analysis, we then looked at the joint tables of the given data to understand the claims, because there were many tables there that others were not related to the claims at all. But then we looked at them, since we joined the entire database, we linked the whole database, and then now we were extracting the things that we think we were going to use, and now we are preparing the data for cleaning. So then we encoded categorical features so that they can maybe use the binary, like 0 and 1s, 0, 1, 2, and those type of things. And then we analyzed the correlations between the variables to uncover fraud indicative patterns. There are many indicative patterns that we used, and then I believe my colleague will explain that. And then we used statistical and visualization tools to examine data distribution and detect anomalies across our data. And then we applied clustering techniques to group similar claims and highlight suspicious outliers. Since we had a very big data set, it was very easy to do that, because when it comes to legitimate things, you can group them easily, and then outliers, you can see them easily by just visualizing maybe a scatter plots, and then you can see. And then now when it comes to the visualization of our data analytics process, we can see on the left we have a table that shows that we have an imbalance on our data set. We have a data set that contains more percentage of fraud, of data that does not contain fraud, and then we have a smaller percentage of data that contains fraudulent claims and things like that, according to how we analyze the data set. And then on the right side, we have the table we have a line graph actually that is showing the number of claims versus the number of chronic conditions that that individual has. So my colleague will continue from here.
Thank you so much for giving me the time, colleague. Before I go on with my explanation of the data modeling, I would like us to have a look at the graph once again. That is actually showing the fraudulent cases versus the non-fraudulent cases. So if you look at this data, you'll realize that there's a gap in between them. And we are building a classifier. So if you are building a classifier, you need to be working with data that is actually in the same level. What do I mean by that? If take this as an instance of an apple and an orange. So if you're trying to build a model that is going to identify whether this is an apple or this is an orange, you got to train it the same way with an apple as with an orange. If you give it 9 apples and you give it 1 orange, it's going to be best in predicting apples than orange. So this shows us that we actually have a big problem to deal with our data set before we go into our modeling. So this introduces the first graph in our modeling over here. This is after we have done all the features engineering, where we have done all the data cleaning, as he was explaining. So if you look into the SMOT graph that we see here, I think this is disturbing us over there. The SMOT over here, it's actually that is going to develop new features so that we can actually have a balanced data. I will show you what do I mean by that. If we look at the imbalanced, so this is where we show you the way we just imported the data set into our working environment, and then we just printed the available columns and the rows. So you realize that we have about 57 columns and that number of rows. And when we have smoted it, it gives you the balanced data that is somewhere on the corner. That's where the cursor is. And the smoted data is now coming up with different columns and with a different number of rows. So now this is actually showing a balance in the data. So yeah, we also actually visualizing the model, that is the random forest model, checking the feature importance after we have smoted the data. I don't know if that's the correct word for it, but yeah. Moving on. So how did we select our model? So in sometimes I wish I had the powers to just, maybe I don't know, use the African way. You throw the bones and you predict, and it tells you which model to actually pick. But in modeling and in data science, we can't do that, right? You can't just think of a model and you decide, oh, I'm gonna use this one. You gotta test out different models so that you can know which one is going to work for you. So we did just that. And doing that, we tested models like logistic regression. That is the one that we are showing you here, comparing to random forest, which ended up being our final model. So looking at the logistic regression there, that is the instance over there. It's showing you the prediction using the important metrics, just like accuracy, your F1, and all those that I mentioned there. So now, it's giving us at 0.67%, showing that it's actually not that efficient, right? And that is actually using the smoted data. And then looking at the random forest that is actually down here, is showing us that it has about 98% understanding of the data. But however, there's a problem in there. So you see that on accuracy, using the training data is actually 98%. But using the test data, which is the data that is what it was unseen to the model, it was the first time it sees the data, it is not doing so well in there, right? However, this is our final model for now. It is not doing so well because there's a big gap between how it predicts the data that it has seen before and how it predicts the data that is unseen. And mostly it's going to work with the data that is unseen in the real world. So this shows a gap that we still need to work more on our model. But because of time, we had to stick to that model. But we believe that we have to improve that by fine-tuning the model, going forward. So that is showing you the correlations of the predictions after we have actually trained that model. And then at the end of the day, the model needs to be deployed somewhere. But how are we going to deploy it? And that is where the download the model is showing you there. We're just simply going to download the model, and then we're going to be using it as an API in our Flask environment, in our case, but it can be used anywhere in any environment that which you want to use over there.
2 minutes left.
So the solution, what did we do? How is the model helping in solving our problem, right? Because that is very much important. So what we did is, as I showed you that we downloaded the model, we went to use it in a Flask application where we can actually deploy it, and we're just about to show you right now, just like a sample of what the model can do. So we'll come to our little website here, not the best looking. One of the professors, the doctors rather, that I follow, he says that a system that is looking so beautiful but not doing any work is just useless, like as a fully fledged car without an engine, right? You can desire it, but it's not going anywhere. So let's just click on start a claim. So this is going to be the medical attention provider, right? I don't know if the perfect way to put it that, but it's going to be the practice. The practice is going to make a claim to your scheme provider, right? So what they're going to do in here, they're going to put details with related to your claim. So why do I actually put numbers in here? There's no user that can understand what I'm doing here. But this is because a model only understands numbers. Our model, our classifier only understands numbers. So I cannot put words in here. But in production, we have to put words because the user does not understand these numbers, what they mean, right? We actually want to say to the user, what is your state? And then they say, in South African context, I'm from Mpumalanga. So what we're going to do in the future is to decode what the user is going to enter so that we can put it in a model. But now because of time, we couldn't manage to do the pre-processing on the data that the user is going to enter. So I'm just going to demonstrate with this data that is numbers everywhere. So now when they click on predict, remember this is on the person that is submitting the claim. When they click on predict, it's going to do the prediction and it's going to send the information to the person that is receiving the claim. That is actually your
Please wrap
medical
up.
scheme provider. So when they see this, it's just telling them that, hey, you got a claim that
You
is
may-
submitted.
You may wrap up 1 minute.
Okay. It's going to show them that this is a claim that which has been submitted and it's likely not a fraud at that percentage. Thank you.
Since we are even out of time, I'm just gonna, if the internet allow us, I'm just gonna show you the limitations that we faced when we were developing our system. So, seems like our Canva is not corresponding, but that's it about our system. But just to highlight them, I'm gonna talk about the database. We faced the issue of the database, but we managed to mitigate. And since the Altron people were there, they assisted with all that they can. And then with our future considerations, we are also considering to implement a chatbot onto the admin side, on the medical scheme side, so that a chatbot that understands the data, so that if maybe the medical scheme, they receive a claim and then it's red flagged, the medical scheme can maybe ask the chatbot to, why is this claim rejected? And then since the chatbot understands the data, it can then respond to the person who's asking it to see it was rejected because of this and this and this, and then the admin or the person who's talking to it can understand why it was registered, rejected. And thank you for your time.
Thank you. Thank you. Any questions? I'm not sure if I'll see on. Any questions from online colleagues? Let me check. Nothing. Okay.
Yes, please.
I'll give to the judges preference. Judges on the floor. Any questions for the team?
Yeah, so I was saying, excellent again. I think this is a practical solution because it is a big worry for schemes. More of a comment to suggest considering the data that is also with the Council of Medical Schemes because they've got all the numbers that can inform this model to work best.
Thank you so much for that. We'll consider that.
Okay. I think there was a hand up from Dr. Jeffrey. Just 1 minute. Just ask your question to the team. Can you hear him?
Yes. Okay, thank you so much. How are we going to do model optimization? So from where we left off the model, you've seen that it was actually able to predict like 76% on unforeseen data. So this means that the model is actually, we used RFE to actually eliminate some features that, according to RFE, are not important. But then, this might actually take in features that are actually important to the model, just not important according to RFE. So what we're going to do is to re-fine-tune the model once again. So this is going to allow us to get even more features that are going to be working based on that model. And another thing that we're going to do is, if you think of an instance of ChatGPT, it was getting to learn as much as it is used. If you remember at the beginning of it, it was actually not even selecting bogus responses because it was not yet trained to actually flag that out. But now it's no longer putting some content that which is not, what is the word for it? Necessary, no, not necessary, but you understand what I mean. So, so what we're going to do is to deploy the model in a training environment where people are going to give it even more data so that it get to learn more on that data and improve itself.
Okay, thank you. It seems like our judges are cool. Let me give you a chance.
Thank you. Quite an interesting presentation. I would have loved to see some of the criteria that your model goes through in terms of coming to a decision to say this is a fraudulent claim, this is not a fraudulent claim. You know, the process it goes through in the decision tree analysis. And the second thing is, of course, you've tried to model the linear regression and the random forest. And the random forest, according to you, was gave you the best results. I would have also liked to see an ensemble, approach where you combine the linear regression with the random forest and see how would that perform when you're combining those two models. Otherwise, brilliant presentation and a good concept. Thank you.
Thank you so much for that. I will take that into consideration.
Okay. Is that good enough for an answer for you? Okay. Okay, I see our judge.
Whose problem are you solving? So are you solving a problem for medical schemes? And and the reason why I ask, because it's been a challenge, right, in the industry where schemes want to prevent all the fraud happening there, but then doctors will want to find another way to make or to go about, looting the system. So if you're solving a problem for schemes or you're solving a problem that will provide that ethical standard for doctors, how do you ensure that doctors don't end up getting frustrated with the relationship with the schemes? So in other words, aren't you creating or disrupting the relationship between the two?
Okay, thank you for the question. So the solution that we are presenting is a solution for for the medical schemes and also for the people or maybe the dependents of some medical schemes. Because like my colleague explained, she said if people are doing these fraudulent claims and then okay, the medical schemes obviously they will see that they are losing more than gaining, so they will end up increasing their monthly payments and things like that, which is going to affect people that are innocent. And then with regards to the issue of the doctor and the medical schemes relationship, so there's no effect that is going to be there because it's just going to be like a normal claiming process, and then the model is on the medical scheme side. The medical scheme is the one that understand with you, okay, is the only one that sees the prediction between of the model, if the model is flagging that as fraudulent or not. So there won't be any effect at all. But thank you for the question.
Yeah, to add on that as well. So remember, the system is just there to say, okay, they submitted a claim to you, but we actually flag this that it might possibly be fraud, right? So now, as you also emphasized that in the future work, we want to implement an AI chatbot that, yeah, the medical team is going to ask, I mean, why do you say this is actually a fraud?
right? And then it tells it on how did it drive that insight to say this is a fraud. For instance, maybe there's missing data that is important on that claim. Then it's going to tell them that, oh, they are missing 1, 2, 3. Then now the medical scheme can be able to make a request to the person that is making the claim to say, hey, provide 1, 2, 3. Why do we do this? We have an instance where one of our lecturers says that she went to a practitioner, and then now they double charged her, right? And it took her for a long time to actually see that. But now if they try to double charge you, this one is going to flag it as a possibility for fraud. So now it's going to tell you on the AI chatbot to say, hey, I think this is actually double charging. And then now they're going to have to consult with both their the claimer and their account holder.
Okay.
Yep.
Maybe a last follow-up from the judge, and then we close the questions.
Potential risk is doctor then suddenly suggesting that instead of dealing with the back and forth with the scheme, because now there's I'm being alerted, I'm performing, and now I must get some further whatever to authorize that for me to eventually get the money. And then suddenly you might end up seeing doctors preferring patients that pay cash than to be dealing with schemes.
Thank you so much. We will try to, I'll see how we fine tune to get to that. Thank you.
Thank you. I see there's a hand online, but we've closed our questions for now so that we can move to the next team. A round of applause for Team Pumalanga.